And we're back with another set of ugly functions to check and see if we are allowed to determine the limit. So taking a look at what we have here, we want the limit as this function approaches 3. So if we're allowed to do direct substitution, then I would just substitute that 3 in and see what happens. Unfortunately, note that I have a 3 minus 1 in that absolute value, which is 2, which we cannot do. That is undefined. So we can't do direct substitution for number 11. Jumping over here to number 12, we're not super comfortable with trig either, but we're talking about cosine. Cosine does have a domain of all real numbers. So we know without even substituting that yes, this will work. Cosine is a well-behaved function, just like polynomials are. So we know that it's going to work. Now we just have to do the work. So I want to know, as x approaches pi, what is the limit of this function? Well, cosine of pi, if you pull out a unit circle, cosine of pi is -1. If we square that, we get a positive 1. So this function is going to approach the value 3. That's my limit. Thanks, cosine. Jumping down to 13, cosecant is not a well-behaved function. So cosecant might be one where maybe you want to head back to the calculator. So our trig functions are hiding over here on the left-hand side. And again, what we wanted was cosecant. We want to know if this limit exists as x approaches 0. So we had 0 plus pi over 2. And we can check and see if that works. Lo and behold, it does. So we were able to get this to work. Yes, direct substitution worked, and our value was 1. So again, don't forget about your calculator. If you see a function you're not comfortable with, check and see. What we're checking is, does substitution work? You can substitute by hand, you can substitute with a calculator, you can substitute with your fingers and toes, whatever you need. Let's jump on over to 14 here. This is one where you can definitely do this without a calculator. Note that we're looking at -5, and we're going to substitute that into x. Is this sucker going to work? Well, that means we're putting -5 in plus 4. So that's a -1 under a radical. No. We're not going to play around with any imaginary limits. That is not a pre-calc topic. So there is no real limit, at least, for number 14. Jumping over to 15. 15, again, this is one that if you were comfortable with the unit circle, maybe you could say right away, hey, doesn't secant have an asymptote at pi over 2? That's not going to work. But if you don't know that right away, feel free to use your calculator. Again, secant is a fairly difficult function. So we wanted double the secant, actually, 2 times secant. And we wanted to know, does this limit exist at pi over 2? So again, you can use your calculator to double check. You can use a unit circle if one's handy. You can use your knowledge of asymptotes, but it's not going to work. So nope, direct substitution does not work for 15. Jumping over to 16. This is one that I would probably use a calculator for personally, but that's no fun. Let's do it by hand. Got to get paid somehow. So in the numerator, we have a 2 plus 4. In the denominator, we have a 2 squared minus 6 times 2, and then minus 16. All right. This is a math one. So that numerator's not too bad. 2 plus 4 is 6. In the denominator there, 2 squared is 4. 6 times 2 is 12. And then we also have a minus 16. So this looks like it is going to work out for us. 4 minus 12 is -8. -8 minus 16 is -24. And 6/24 is 1/4. So that one did work out for us. And this is our limit. What's nice about 16 is it does kind of show you that even though we have a rational function, which is not a well-behaved function at all, that does have vertical asymptotes. Even though we have that bad function, direct substitution did still work. So as we start moving forward and looking at some more difficult algebraic methods, it's important to remember, check direct substitution first. It's just plugging in a number. If that works, you can save a ton of time not factoring, not rationalizing, not doing too much extra. So start with this. If direct substitution works, move on. Direct substitution doesn't work, well, that's what the next section is for. Hope you're enjoying your substitute experience, and I'll see you soon.